In this section, let us understand the network capability. Okay, so this is a sample workload with ALB. So let me go ahead and deploy this workload. So I've created the namespace, and this is the deployment object. Okay, so this is straightforward standard application, and I'll also create a service. That's also deployed. Now let us create a ingress class. Okay, so this is important to note. So we have to use this particular ecase.amazonaws.com.alb, okay, as a controller. This is different from the default ingress controller that we use in the ingress class definition. Okay, so this is different in the ecase auto mode. So let's create that. Then I'm creating a ingress. Okay, so the ingress class name is ALB and the controller is this. Okay, and so I'm just creating a simple routing for this service and using the target mode IP internet facing. Okay, so it is created. Now let us verify whether the pods are to the running state. Okay, so all the pods are running. Now let me look at the service. Okay, so this is a service, and let me also get the ingress for this service, and this is the load balancer that is created for the ingress. So let me go to my console and go to the EC2. So within the load balancers, I can see that this particular DNS name is what we can use for the service. So this is still in the provisioning state, so it will take a while to create it. Let us wait for a few seconds. So the application load balancer, which is internet facing, is ready. It is in the active state. So if I go to the target group, I see the 5 pods registered. And if I go to the domain name, so this is how the application is working. Okay, so that means we are able to create a ingress with application load balancer in the EKS auto mode. Okay, in this section, let us deploy a sample workload with NLB. Okay, so this is a typical Nginx deployment. Okay, so let me just go ahead and deploy that. Then we have a service object. So it's important to note the annotation that we are using and also the load balancer class. This is important to keep in mind for the auto mode. So apart from the load balancer type load balancer, we also need to provide this for the auto mode. Okay. So let me get the services. So the NLB is created. So let me go and check within the load balancer section. So this is still in the provisioning state, and here it is at the port 8080. Okay, so let me just open this target group, and I'll also get the DNS name for this. So it is at 8080. So let us wait for some time till it becomes active state. So the pod is in the initial state. So let's give it some time. So the load balancer is in the active state. Okay, and this is the listener 8080. So if you look at the website, okay, I mean the DNS name at 8080, we have the Nginx running. So that means we're able to create an NLB in the EKS auto mode as well. In this section, let us understand how to create network policies in EKS auto mode. For that, we have to deploy one config map. The name of the config map is this, Amazon-VPC-CNI, and this is created in the Cube system namespace. And important thing to note is this particular field we have to enable network policy controller true. Okay, so this is all required to enable the network policies. So let me select this and run this inside the cluster. Okay, so the network policy is created, and from here onwards you can use the standard star examples to create any Kubernetes network policies using the default VPC CNI capabilities. You don't require to deploy any third-party controllers like Calico in this case, because VPC CNI natively supports network policies. Okay, so this is how you can enable network policies in EKS auto mode.